Hello to everyone. I am Professor G. N. Deshpande. Today we will discuss the numerical based upon the Spur gear. So the statement of the numerical is like this. It is required to design a pair of spur gear. So here from this particular line, we will understand that the spur gear need to be designed. The dimension for the spur gear is it is a 20-degree full depth involute teeth system, which consists of a 20 number of teeth of pinion, which is meshing with a 50 number of teeth of gear. The pinion shaft is connected to a 22.5 kilowatt electric motor who is running with 1450 rpm. The starting torque of the motor can be taken as 150% of the rated torque. The material for the pinion is a plain carbon steel, uh, which is having a grade EFE 410. The ultimate tensile strength of the pinion material is 410 Newton per millimeter square, while the gear is made up of grey cast iron Fg200. The ultimate tensile strength is 200 Newton per millimeter square. The factor of safety is 1.5. We have to design the gear based upon the Levy's equation and using the velocity factor to account for the dynamic load. So this is the statement of the numerical. So from the statement of the numerical, then after reading the statement of the numerical, then we have to first of all write down the given data. So the procedure for solving the numerical of this per gear is like this. We will solve this numerical in three steps. The first step is nothing but write down the given data. In the second step, we'll write down the to find or the to calculate data, and in the third step, we'll write down the required formulas required to solve that particular numerical, and then put the values, and then we will get the final answer. So as the statement of the numerical is already understood by us, so we would start the solution by writing the given data. So first of all, write down the given data. The power of the electric motor, that is kilowatt, is given 22.5. Then the speed of rotation of pinion, that is n suffix p, is given as 100 and 1450 rpm. The number of teeth of the pinion is given as 0.5. The factor of safety is given as 1.5. The ultimate tensile strength of the pinion is 420. The number of teeth of the gear is 50. So starting torque 110 Newton per millimeter square, and for the gear it is 200 Newton per millimeter square. So first of all, we will start the solution by deciding the weaker element between the pinion and the gear. So as we know, for this particular numerical, the materials of pinion and gear are different. So we have to go to the design data book, and from the design data book is equal to 150% of the. We have to take the values of Levy's form factor according to the number of teeth for the pinion and number of teeth for the gear. So the value for the number of teeth is based upon the number of teeth of pinion. For the Levy's equation is capital Y is equal to 0.32 for the pinion and 0.408 for the gear. So next is the bending stress. So the bending stress is calculated as 1/3 of the ultimate tensile strength. So for the pinion, the sigma B is equal to S suffix UT upon 3, which is 400.67 Newton per millimeter square. So the product of sigma B into Y will decide the weaker of the two elements between the pinion and the gear. So it is 136.67 multiplied by 0. 200 divided by 3, which is 0.32. The answer is 43.73 Newton per 66.67. Unit is Newton per millimeter square. The product of sigma B into Y for the gear is 66.67 multiplied by 0.408, which is 27.20 Newton per millimeter square. So when we see these two values, that is for the product of sigma B into Y for the pinion and the product of sigma b into y for the gear, the sigma b into y product value for the gear is less than the value for the pinion. So therefore, out of these two, that is pinion and the gear is a weaker element. So the here the product sigma b into y is less for the gear. So hence gear is a weaker element of the out of the pinion and gear. So therefore, there is a need to design the spur gear based upon the gear. So this is here we concluded the first part. Now next is a determination of the module based upon the beam strength. So the standard formula used for determination of module is small m is equal to 60 into 10 to the power of 6 divided by pi in the product inside of the bracket kilowatt multiplied by factor of safety cs multiplied by fs divided by z into n into cv into b by m into sut upon 3 into capital Y. Here all the notations are used with respect to the gear because we are designing the gear as gear is a weaker element. Rest 1 by 3 is the factor. So in this particular M formula, kilowatt is known to us, which is 22.5. C suffix s is known to us, that is 1.5. F suffix s is also known to us, that is 1.5. The number of teeth of gear is known to us, that is z suffix g is a 50. Then n suffix g is not known to us. Then c suffix v is also unknown to us. Then b by m is also known to us because here we will consider the face width as a 50%, face width as a 10 times the module. Yes, you T upon 3 value is also known to us, which is 136.65 and capital Y is 0.408. So all these values are known to us. Only the two unknowns, that is one is n suffix g and c suffix v. So for calculation of n suffix g, we are using the basic relationship, that is transmission ratio I is equal to the ratio of number of teeth of gear to the number of teeth of pinion. So it is a 50 divided by 20, and the same thing is equal to the number of is equal to the speed of rotation of the pinion to the speed of rotation of gear. So the formula is converted, and the value of n suffix g is calculated as 1450, that is the speed of rotation of the pinion multiplied by the number of teeth of pinion divided by the number of teeth of gear. So n suffix g is 580 rpm. Then the velocity factor CV that we have to calculate. So for that reason, first of all, we will consider or assume the velocity, pitch line velocity value is 5 meter per second. So if pitch line velocity is less than 10 meter per second, the formula for determination of velocity factor, that is C suffix V, is 3 upon 3 plus V. So it is 3 divided by 3 plus 5, which is equal to 3 by 8. So now we get the value of Ng and Cv. So substitute all these value in the equation M, which is equal to 60 into 10 to the power of 6 divided by pi, multiply by kilowatt, multiply by C suffix S, multiply by factor of safety, divided by Zg, Ng, Cv, B by M, SUT upon 3 into Y, capital Y. So the final answer for the module is solving is 6.89 millimeter. So this is the module of the gear. Now as this value 6.89 is a fraction value, so we will take the preferred value from the table which is mentioned in the design data book, and the choice for our selection value as 7 millimeter. So if module value is 7 millimeter, then the diameter of the pinion of the module is calculated by using the simple formula, product of module with the number of teeth of pinion. So M into Z suffix P will give you the value of diameter. M is equal to 7 millimeter. So now we will consider the modulator of the pinion. 7 multiplied by 20, it is 140 millimeter. Similar way, we will calculate the diameter of the gear, that is d dash of g, which is equal to again the product of module with the number of teeth of gear. So it is 7 multiplied by 50, so it is 350 millimeter. In the same way, our assumption is that the base width b is 10 times the module, so it is 10 multiplied by 7, which is a 70 Now we will check for the design of the gear. So first of all, we will calculate the bending moment of the gear. So bending moment is represented by m suffix t, which is calculated by the formula 60 into 10 to the power of 6 multiplied by kilowatt divided by 2 pi ng, which is equal to, if we substitute all the values, we will get the bending moment m suffix t as 3,70,446.85 Newton millimeter. So once we get the value of m suffix t, that is the bending moment, we can calculate the tangential force acting on the gear by using the same value, with the help of a formula, that is a tangential force p suffix t is equal to 2 times the bending moment mt divided by d dash of g. So 2 into 3,70,446.85 divided by the 350. The final answer for the tangential force p suffix t is 2116.84 Newton. So here we get the p suffix t, that is tangential force. Now if we want to calculate the pitch line velocity, then v is equal to pi d n divided by 60 into 10 to the power of 3 is the formula. So this is for the pinion. So it is a pi multiplied by 140 multiplied by 1450 divided by 60 into 10 to the power of 3. So the v is equal to 10.63 meter per second. As the velocity value is greater than 10 meter per second, so the formula for calculation of velocity factor c suffix v is modified, and it is 6 divided by 6 plus v, which is equal to 6 upon 6 plus 10.63, which is 0.3608. Okay. Now next is we have to calculate the effective load acting on the particular gear. So how to calculate the effective load? Effective load is calculated as P effective is equal to the CS, that is a service factor, divided by the velocity factor, and whole is multiplied with the tangential force. So if we substitute the value, that is CS is as 1.5, P suffix T as 2116.84 divided by velocity factor 0.3608, the P effective is 8,800.61 Newton. So this is the value of the P effective. Now we will calculate the value of the beam strength, and the formula for calculation of beam strength, that is S suffix B, is M into B into sigma B into Y. And if we substitute the values of all the parameters, that is M as a 7, B as a 70, sigma B as a 200 divided by 3, and capital Y for the gear is 0.408. The final S suffix B value, we get 13,328 Newton. So by seeing the two values, as the beam strength value is greater than the P effective value, so therefore the factor of safety is calculated by using the formula, that is beam strength divided by the P effective load. So it is a 13,328 divided by 8,800.61. So the final factor of safety is 1.51. So by seeing the factor of safety greater than 1, we can say the design is safe and the design is satisfactory, and hence the module value given, or the module value that we have considered is 7 millimeter is the correct value. Okay.